Oh boy. Hello. Hi, welcome to Chicago Kotlin User Group. Thanks for your patience. Please let me know if there's any issues with connectivity or lag. Just like comment it, we'll keep an eye on that. So we're in for a treat today. We have a special guest, Maia. And Maia is a current Android GDE. She also did this talk for Kotlin Conf 2024. Is that right?
Yep, that's right. It was for last year's Kotlin Conf.
Wonderful. Yeah, no, it's I haven't had a chance to look at the talk, but I did have a chance to kind of like look through some of the GitHub, and it looks really interesting. I think one thing that I don't do data science, and maybe that's one clarification. I look at the talk description and the title, and I'm like, oh, okay. Like maybe this is a talk that could be for everyone.
Yeah, so I don't do data science either. I do Kotlin, but JetBrains announced the notebooks, and I like to call myself a shiny new tech magpie. And so I jumped on the Kotlin
What?
notebooks
Sorry,
and I
one
tried
more time.
a shiny new tech magpie. So when new tech appears on the scene, then I jump on it and I try it out. I think you're lagging a bit, Amanda.
I believe so. Hold on, I'm going to switch networks and see if that solves the problem.
Okay. So for everybody else in chat, if you've used notebooks before, I know one person's used notebooks, you can tell me. But I'm not a data scientist either, but they're super, super useful for just messing around and trying things out. And so that's what we're going to do today. We're waiting for Amanda to get back. So I write lots of Kotlin code. Are you back?
How about now? Can you hear me now?
Yes, I can hear you.
Okay, so wonderful, wonderful.
Mm-hmm.
Yes. So sorry, could you just like reiterate the question one more time? Just like quick background. Are you a data scientist? I do apologize.
No, I'm totally not a data scientist. I write Android code and some KMP code. And so I write Kotlin for apps daily. But when the notebooks came out, when JetBrains announced the notebooks, I thought I wanted to give it a try because, as I said, I'm a shiny new tech magpie. So I collect shiny new tech experiences. And so I started messing around with the notebooks, and it was so much fun. And it was really, in a way, liberating, different to when you're writing a project with a build Gradle and with all of the trappings of an app. So it was a place where you play.
Yes, that's incredible. So you said you use this to kind of like try out MVPs, and this is because your traditional background is Android developer.
Yes. So not so much MVPs, but just if you've got like a snippet of code, when you want to try something out, you want to try something out with the coroutine, maybe you want to try some little piece of algorithm out or try some visual thing out. And then or you have a snippet of code that you see in a book and you just want to see how it works. And then you don't want to have a whole project around it. You just want to try something out. This is really useful for something like that.
Oh, I already have questions, but I feel like that would take the show away. I'm really excited to see how it is. And here's what we'll do from here. If you're just joining the show now, welcome. We're about to get started. If you haven't done notebooks before, like kind of think Jupyter Notebook. I'm not sure what the other alternatives are, but Maia's proposal is that anybody can use it, especially for like trying out things, taking notes. So I'm personally really interested in this because I always thought, oh, this is like for data scientists. So I'll be asking a lot of questions along the way, and I'll also be watching for the chat. Just note there's a little bit of a lag with the chat settings specifically. So maybe I'll try to pull up the version on my phone so I can see it faster. But yeah, go ahead and voice the chat. This won't be so much of a traditional talk format. It'll be a bit more conversational and quite literally a walk in the fractal forest. Who's Lindenmayer anyway?
Oh, no spoilers, Amanda. I can't tell you now. We'll
Oh,
get
okay,
there.
okay, no problem. I
We'll
can't
meet him
wait.
in the forest. We'll meet him in the forest.
Wonderful. All right. And also, just as a quick note, you know, a lot of my tech is going a little wonky right now, and I'm, you know, just one of those things. And what I might do is after our intro, I'm going to put you on for a few minutes, and then I'm going to locate headphones that are functioning.
Okay.
Yeah. What?
That's all
So,
good.
okay, cool. I'll bring you back on stage in just a little bit, and we'll go ahead and get started. All right. Welcome to Chicago Kotlin User Group, located in Chicago. We do have a lot of in-person events, but since the pandemic, we kind of kept this occasional hybrid format. So if you're ever interested in doing a talk, we do have a 2025 CFP. I'll be sure to drop it in the comments. Yeah, okay. So a little bit about the Chicago Kotlin User Group. We believe in being inclusive. Chicago Kotlin User Group is an inclusive and accessible group that this is why we mask up is obviously very old at this point. But be curious, ask questions, and avoid assumptions, and do everything you can to continue to grow trust, empathy, and friendship. Yeah, there's that talk. Want to give a talk for 2025? We take nearly every single one. New speakers are especially welcome. It is a safe space to practice talks. It's a great way to expand your network, and it always looks great on a resume. So definitely give a talk. You know, we usually give feedback on the talk too. So yeah, this is a really great space to like kind of try out something. It could be like internal projects. It could be a personal project or a school one, or yeah, if it's anything Kotlin related, we're always interested. There's never been a bad talk. Okay, there are a few ways to keep connected with online with Kotlin user group. So we have the Kotlin Lang Slack. We're on the Chicago channel, and we do have a Mastodon. And, you know, actually, we're kind of in a weird place with this right now. You know, there's been a couple flips with social media. So I think I'm going to have to update this for the next talk. But I think the current thing we're probably going to try out is following personal social media accounts. So I'll go ahead and post my personal socials. And that is what we're trying out until we have all decided on what platform we're going to hang out on, which is probably going to be LinkedIn. But, you know, there's like, how many of you have like 4 or 5 accounts? It's exhausting. And now I got to do like this other one on top. So yeah, we're just going to, yeah, I'll go ahead and post that information as well. So that's what I'll do throughout the talk. Okay, there's also a Chicago Java user group. We are connected with Java user group. So if they do have a LinkedIn group that is very established, we can definitely take some lessons from them. We do a lot of crossovers because that's the fun part about Kotlin. We can do lots of crossovers with other groups, and they're kind of like our sister group. So yeah, we do have a YouTube. Is this a channel? I guess, but we do have some talks from the past, so you can catch Maia's talk here at some point after the recording. Oh, also out of date, nobody's hosting us other than StreamYard, so thanks to StreamYard for hosting us. I think that's kind of everything that I have for today. Yeah, I guess I'll go ahead and invite Maia back on stage. And Maia, if you have yours, we're going to flip to yours.
Okay, I'm ready.
If I can. I think I have to talk really nice to the computer. Maybe I have to take my, okay. We love software updates.
Yes.
Okay, I'll be back on shortly, but I am listening. And
Okay. All right. I'm going to just jump in right in here and talk to everybody and tell you what this is about. So if you look at the screen, it looks like you're in a slide software, but in fact, we're not. We're inside presentation view of IntelliJ IDEA. it's the Ultimate Edition, so the Kotlin Notebooks are in there, but I think you can also get the Kotlin Notebooks in Android Studio. And what I'm not so sure, I think you can see everything at the top here, but you can see I'm in IntelliJ idea here because of this bar at the top here. And this bar over here. These are the controls for the notebook. You're seeing a JPEG that's coming from my disk, but let me pull the curtain back and show you the notebook part. So in the notebooks, the great thing about notebooks is it's just a file. It's got a specific, it looks like it's a Python file, but it's the same extension as the Jupyter notebooks. And you can have different kinds of cells in the notebook. You can have a code cell. These two are code cells. And I have a small snippet of code. The interesting thing about these code cells are that if the piece of code inside the code cell spits out text, it's going to show you text. For instance, I think I'm going to see if I can get this here. If I write print line, I'll see if this works. Now, this green arrow here, so you can run this, and you'll see whatever the cell outputs, the text appears. So it's really useful for seeing immediately what your code is doing. It also understands buffered images. So that's the Java buffered images. So what this thing is doing here, this display, it's reading that image from a file. This is a method that I created over here. You pass the name, it reads the name of the file. And then here you can see, in fact, what I'm doing here is I'm showing the JPEG. And that's how I get this image. And so the title of my talk is A Walk in the Forest with a Notebook. It's a reference to paper notebooks. I really love paper notebooks because you can scribble in them and you can draw things in them and you can think and make some notes in them. But the problem with a paper notebook is you can't code in them. So this is also a walk in the Lindenmayer forest. We'll see who's Lindenmayer in a minute or two with the Kotlin Notebook. And I'm Maia Grotepass. I've been introduced as well. If you look on the internet, Maia Today, that's my handle. You'll see there's a website with a lot of blog posts, or if you try and find me on socials anywhere, and on GitHub, you'll be able to get me with this handle. The other thing that these notebooks have is they don't only have code, they also have Markdown. So you can make notes about your code inside the notebook. So this is for people who've used Jupyter notebooks before. It's the same as a Jupyter notebook, same format. It's just that it's Kotlin and not Python. And so if you tap in here and you look in here, you can see, I don't know if it's going to let me edit this now. But in any case, this is Markdown and it's rendered Markdown. And this is what the code snippet looks like. And so I think you can convert these cells from Markdown to code. And also there's a new feature in the Kotlin Notebooks is you can do some AI things as well. So you can, if you click on the AI, you can actually write a prompt inside one of these cells, and then it will use the rest of your notebook as a context. So since this is a walk in the forest, I want to take a definition of what is a road and what is a path. And this quote is from Milan Kundera, and it's from this philosophy of walking. And the definition of a road is that you want to get from A to B. So it's like a rope leading from one place to another. And a path, by contrast, is a tribute to space. So it's like an exploration of space. It crosses space along the way. So it's like it opens up a wood or valley. It's a source of revelation and discovery. And for me, from a coding perspective, if I'm coding a project, if I get a requirement and I need to deliver a requirement, it's like a road from A to B. But the notebooks allow me to explore because I can have code in the notebook and I can explore on the code and have a look. And so just because of that, we are now going to take a detour. So what I'm doing is Command E, and I'm going to jump into a detour. So in a paper notebook, I can draw, I can write, but I can't code. In a Kotlin notebook, we've seen I can code, but can I draw? So what I'm doing is I know these cells, they can output a buffered image. And so if I can create a buffered image, so what this thing is doing over here, it's creating a buffered image. So if I change this number here, say to 300, and I run the cell now, if I'm lucky, you can see it's changing the code here. So let's make it 100. Let's make it 10, and you should see the difference. So you can see here that it's only outputting 10 of these circles. What's it doing inside here? This is a snippet of code that I have. Now, the cool thing about these notebooks are you don't have to stay inside a notebook. What you can do is you can pull in your own code from your project. And so for this, I have code in my project. And how you do it is on this drop down here, you can add other pieces. So there, Forest Walk main, that's the source code. Classes that I've created inside this project that are just ordinary Kotlin classes. So if you've got code that's in your project, you can still access your project code from your notebook. And so what we're going to do now is we're going to jump into this class, this canvas class, and it's sitting over here. Now, I told you that that notebook cell can output a buffered image, but in Java, buffered images are a pain. They've got a bunch of stuff that you've got to set up. Now, I could have put that code inside the notebook, but what I did is I made a little function here. I think the font is big enough. Let me see. I can make the font a little bit bigger. I made a function that takes Sierra Lambda with receive, takes a function as an input over here. And this canvas function, because this block function is the last one, you'll see the syntax that we can use to access the block. It outputs a buffered image. So it actually returns the buffered image. And what I'm doing inside this canvas is I'm doing all of the boring Java things that Java needs for the buffered image to come out. And then over here, once I have the buffered image, I can just call this block. So I'm doing some things with width and height, but I can just call this block, which is this function that gets passed into this canvas object. And then, so this is the plumbing underneath, which outputs a buffered image so that the notebook can render it. So let's jump back into the notebook and you'll see here.
Questions.
Yes, questions. Start, go, questions.
Yeah, okay, all right. So a few questions. So if I understand correctly, you can grab code and dependencies from your own project on top, and the rest of these imports, did you configure Gradle dependencies into this project to make this work?
I don't think it's Gradle dependencies. I think Gradle just has your project as your Gradle, but this notebook can access, I think it accesses the Java classes that get run in the build. So I don't exactly know how the build works underneath, but you don't have to change anything in your Gradle project. So theoretically, if you've got an Android project with its Gradle project the way it is, you can have a notebook and just pull in classes like from there. So if I open up these imports here, this package, this one, this canvas package lives elsewhere. So maybe it's easier if I just go like this and I switch out of view mode, exit presentation mode. It's going to be small now, but what you can see on the side here, this is where my notebook lives. It lives over here. There's my notebook. And then I've just got a normal source with main with Kotlin and normal pieces of code. So that canvas code lives in there, lives inside any other project. And I've got nothing about the notebooks in my Gradle file. So my build Gradle is just my normal build Gradle. But the notebooks have a way of finding the sources and compiling it in when it's running. So I'm going to jump back into, Does that make sense?
This makes sense. Yeah. So you have a source code set that you have configured in here, and that does include Gradle dependencies. And then on top, you have a book folder, which I guess is like kind of like the structure you need to work with Kotlin Notebooks. Is that correct?
Yeah, you don't need a book folder. I think you can put the notebook anywhere. I think you can put the notebook in the root folder as well. I just put it in book
It's just kind of okay. Yeah. Cool. Yeah.
So I can show you. I'm going to show you later how we pull in dependencies, but the way that you hook it up, the way that you hook it up is basically by telling it here that I want to use the forest walk. That's my project, and I want to use the code that's in the main. If I needed to add, if I had some code inside test that I wanted to add, then I would click that one. But so if I unclick this, then when I run this with this run button over here, it won't work because it'll tell me that it can't find the canvas function.
Okay.
Okay.
Yeah,
And
very
so
interesting. Okay, I'll continue. Sorry.
Yeah.
And also,
so this
folks,
spot here.
So sorry, I was about to say, folks, feel free to drop questions in the chat as well, and I'll be sure to voice them.
Okay.
Yes,
so this part here is a function, is that function that's the parameter into the canvas. And inside here, I can do things now. Like, so I can decide to do things. So here's the same canvas function, and I'm repeating 200 times, and I'm going to run this now. So when I click run here, it's drawing little rectangles all over the place here. Or I can, on the same canvas, there's another function called Poisson disk points, which I have, that just distributes these points evenly spaced from each other in random places. This random color is just a helper function that I have for random color, and then it can do something like that. And so the trick to get this to show is because this canvas function outputs a buffered image. Okay, so that was the detour to show us how we can draw inside a Kotlin notebook. This is not the normal way people draw things in data science notebooks. In data science notebooks, they usually have some or other candy or some or other library that they pull in that they can use to plot. But I wasn't going to draw. I wanted to see if I can actually physically draw on the canvas inside a Kotlin notebook. So let's just jump back into the forest. Okay, so now we did the detour. And so now let's get on to Benoit and the Beast. So now let's move into fractal territory. So this person on the left here, it's the first person we're meeting in the forest, and his name is Benoit Mandelbrot. You might have heard of the Mandelbrot set. He was a mathematician, not a data scientist, but a mathematician. And the mathematicians had functions which they called monster functions before. But Benoit Mandelbrot called himself a fractalist, and he called those functions fractals. And so I've got the unicorn here because it's a reference to something being a monster or not a monster, and giving something a name. And the interesting thing about these functions, if you think from a mathematical point of view, if you have a function that describes a line, you can zoom into that line, and no matter how much you zoom into the line, it's still a straight line at the bottom. Even if you zoom in, it stays a straight line. These monster functions, or these fractals, their characteristic is that if you have a way of plotting them, the more you zoom in, the more complex it becomes. So it's not a line anymore, it becomes more complex. And I'll show you what that looks like. So this is the famous Mandelbrot set that everybody knows. And the way it's defined is that the black are points that are not part of the Mandelbrot set, and the outside points, the ones on the outside, are points that are not part of the Mandelbrot set. So it's like inside, outside. But the interesting thing with this one is that if you zoom in, so say for instance you zoom in about here, it's going to start looking like this. So you can see the surface here becomes more and more and more complex. And if you zoom in on any one of these tiny little things, little horns on the side here, it zooms into something like this. So that's why they were called monster functions, because you can zoom in and they become more complex as you zoom in. And they're what they call self-similar. So it means that something over there, it's not exactly the same as this over there, but it's got a similar, there's a similarity. The other thing about fractals are they're super simple in construction. So the formula for a fractal is really quite simple. And now I'm going to demonstrate another thing you can do in these notebooks. You can pull in a library. So that percent use is how you pull in a library. So that's a way of getting a dependency. Like you would get a dependency in Gradle, you can pull in a library, and you can use LaTeX. So you can have formulas that show LaTeX formulas or mathematical formulas. And the formula I'm going to show you here is the Mandelbrot set formula. And how this works is...
Sorry, just to slow down and make sure that everyone understands. So if I'm understanding correctly, all of this is mathematical equations that generates computational images based on these models?
Yes, so it's a formula that if you plot it, then it will generate those pictures. If you have a way to change the formula into something visual on the screen, then it generates those formulas. And the mathematicians knew about this, but at the time of Mandelbrot, it was the first time that they started plotting these functions with computers. And so you could see what they looked like.
So they actually created these images with computers. This is like what year is this?
I think it's around 1980s. I'm not sure the exact dates of this. There are links in my references, so you can have a look and see exactly what Mandelbrot was doing when he was doing that. It's relatively recent.
So cool. Okay.
Okay. So how this formula works is you start at 0, 0. The Z is a complex number. So it's got an X and a Y. So they plotted the X and the Y on the graphs. And what you do is there's some other constant, and then you square Z to get the next one. Then you take the answer and you plug the answer into this formula again, and you repeat. And so it's like a snake eating its tail. That's what the formula is. That's how you generate it.
What? It's a self-consuming algorithm?
Yes. And if this algorithm goes to infinity, then it's on the outside. If it doesn't go to infinity, like if you put 0 in here, 0, 0, and some other constant, and the constant was 0, then no matter how much you squared this would stay at 0. It would never fly off to infinity. And then it's black. So then you draw that point, that starting point, you draw that point as black. If it does go to infinity, it's on the outside. And it's on the border of where these numbers either go to infinity or don't go to infinity that you get this Mandelbrot. That's the outline of the Mandelbrot set. Okay, that's the underlying thing. We're not going to draw the Mandelbrot set. We're going to draw some other ones. The other characteristic of these fractals, which is fascinating, is that they have surface complexity or dimension. So when you zoom in, you can see the lines become more complex on the surface. Okay. You wanted to know who Lindenmayer was. So enter Aristid, I think I'm not saying his name, Lindenmayer. So he wasn't a data scientist either. He was a botanist, I think. But he was interested in how plants grow. And he wanted to write an algorithm to explain how plants grow. So he created this kind of language that you can use to say how plants grow, like maybe a stem starts and then it branches, and then at this point the branches branch out. So he made like a book that you can, like a formulaic way of explaining how plants grow. And so what I've done here is I'm going to demonstrate to you how Lindenmayer, how his formulas work, but I'm going to use emoji. Okay, so imagine you had this plant. You start off with one emoji. We're starting off with a rock emoji. And then inside this plant, I've got a bunch of rules. And the rules say, if you see a rock, substitute it with a rock and like a sprout. If you see 4 sprouts, substitute it with this string. If you see, and so on. And then this grow method is a repetition. So it's like that self-eating function that I showed you before, the fractal function that I showed you before, but this one does the same thing. So whatever the output is, you start with a rock, that's the starting coordinate. You start with a rock and then you do successive replacements. So if I run this now, you'll see here. Okay, let's just do it 2 times. Let's just do it 2 times to show you. So you see I started with a rock. The rock was replaced by a rock and a sprout. And then I ran it again, and then the rock was replaced by a rock and a sprout again. But you can see if you make this longer, if you make this more, it becomes more and more complex. And it becomes so that it's not regular necessarily. So Lindenmeyer's way of the Lindenmayer algorithm isn't a fractal in and of itself. but it's got that characteristic that there's an algorithm that where it takes the output of the algorithm and then it applies the rules to it again, the same way that the Mandelbrot function was. And because you can do that, you can actually end up with something that has the potential of having a fractal nature, because it's got that recursive. So it's got the characteristic that it's really simple, and that it's got the recursion, and that it can become quite complex. We can jump into the plant function quickly, and then I'll show you what that looks like. I think it's in there.
Yeah, let's dive into the source code, because I'm looking at it and I'm now seeing that, so these are mathematical concepts that you applied yourself. And the part that's kind of blowing my mind is this connection between the display of the emojis on the notebook and the implementation that you created. And
okay,
I just
so
linked yeah, sorry for the viewers online. I just linked the class that I'm looking at. Okay. Go ahead, sorry.
So I have this data class. It's got the seed string. That's where we put the rock in. And then it's got these rules, which is just the sequences. You choose the rules, which are the rules that you apply one after the other. And then the output is what I call a blueprint. The iterations are how many times it must repeat. And I've got a simple builder, which will create this plant from these values. So that's just builder pattern to set up this data class. And the way that it looks like in the notebook is this function, which has a function passed into it as a last parameter that applies that block and then builds the plant. So this is just Kotlin builder pattern and functions as parameters. What you want to see is this grow method, right? So what this does is it says, how many times am I supposed to repeat? I take the seed and then I repeat however many times I must repeat. And then for each of the rules inside whatever my starting thing is, I literally replace the old value with a new value. So it goes through the rules one by one and it replaces it.
Oh, wow. Okay. So it looks like you're actually drawing everything out based on the Lsystem class.
Yeah. So that runs, creates some other string, which represents the plant. And then you see the emoji. So I'm just, if I jump back into the forest, this is just, this blueprint is just the result. So it just prints out, because this section in the notebook, the cell in the notebook, whatever you do last, it will show you what it is. So this is just doing a print line. Because blueprint is a string, that just outputs the string.
All right. How different is this? Well, I guess, no, we're already seeing some of the differences between this and a Kotlin playground. I'm sure folks have worked with the Kotlin playground before, because the capabilities are a lot more, especially with the ability to, okay, sorry, I'm going to ask a newbie question because I don't know much about notebooks. So far you've shown us that you can put in images in the notebook. Is that a drawing, by the way, or is that a code rendering as well, just out of curiosity?
No, this is just a JPEG, which I'm drawing with this show method.
Cool.
So this is just a JPEG.
No, that is cool. Yeah. So it's like, I guess I'm kind of thinking about Tornado FX because I've rendered UI that way. Could we say that Kotlin Notebooks is kind of a UI framework? Is that a weird way to put it? Yeah.
I don't know. I don't see it as a UI framework. I've seen people do compose in it recently. But the core of it, though, is that the notebooks can render things.
Okay.
They can render, this renders a string. But if the last thing that you output is a buffered image, then it renders the image. Wow.
Okay. No, this is really fun. I actually started looking in the data science channel on the Kotlin Link Slack too. I'm like, what are other people making? It's kind of fun. I'm seeing some, so this is really cool. continue. Sorry. And
No, no problem.
also, I'm full of totally newbie questions on this topic, so don't be afraid to drop in questions of your own as well.
Yeah, so the newbie questions are great because I'm also not a data scientist, and so the newbie questions are interesting for me as well. And I'm sure people watching this would love the newbie questions as well. I'm moving on to our first animal that we meet in the forest. So this at the top here, that's a turtle. I call that a turtle. But in some places of the world, they call all of these things turtles.
They're all turtles. Wait, are they not tortoises if they...
Okay, so
I don't know. Who knows?
If they live in the sea, I think they're a turtle. If they live in a river, they're a terrapin, this one. And if they're on land, they're a tortoise. By my definition,
Oh my
but
God.
I know in some places
no,
everybody
that sounds
calls
correct.
Okay, so why do I have this here? Why do I have this image here? Because there was, I think, in the 60s, they built like this mechanical turtle with a pen inside it. And the pen, you could control they called it a turtle. That's the logo turtle. You could control that turtle with code. And you could make it walk forward, and you could make it turn, and you could make it put the pen down and lift the pen up. And people were drawing things with this turtle. And so the way that you draw onto the canvas, so this is the connection with the tortoise, is that I wrote a piece of code that's called Tortoise, and it does that. It does the same as that logo turtle. It can draw and it can take commands. The reason I did that was because you see those emojis at the top? You can translate that into drawing commands. And if you translate that into drawing commands that the tortoise understands, you can draw these images of growing things on the canvas.
I found the canvas code. I'm going to drop it in the chat.
Okay, so the commands are, if it's a big F, put your pen down and draw a line, basically. Move forward for a certain amount of steps. If it's a small f, don't put the pen down, just draw. If it's a plus, you rotate by an angle clockwise. If it's a minus, rotate by an angle anti-clockwise. And then this left square bracket is interesting because what that means is it means push your last position onto stack and continue. And if you have the opposite square bracket, it means pop your last position. So maybe make the tortoise jump back to its last position on stack and continue drawing from there. And then the back tick gives you a change of pen color. And any other character that you have, it is ignored. So if you fill the plant class that I showed you before with strings that can do these commands, it will draw them on the canvas. And so I'm going to show you what this looks like. Koch curve. Okay, so here we can see the seed is draw a line, turn, draw a line, turn, draw a line, turn, draw a line, turn, which should draw a little square. And the rule is every single time you see a big F, replace it with this long thing. So if I now do this blueprint, the seed, we'll see what the seed looks like. We can go into the tortoise code in a minute and have a look at that. So if I run this now, there's a little square. So that's what it starts with.
Okay.
It's really tiny. Is it really tiny?
It's so tiny. I see it though.
Okay.
It's so cute. Okay, cool. Okay.
And then if I replace it with this string, and we run this now, you'll see a tiny little squiggle. So every time it sees an edge to the square, it's going to replace it with that squiggle.
Okay. You know, this is I did a project in college over the summer that actually demonstrates a similar kind of beautiful. That is so cool. This is a really cool way to draw math with images, and it's a great way to think about computational models without code. And this is like kind of a nice little framework for that, even though we're talking about notebooks, but such a cool concept.
Okay. Do you want to go see what the tortoise code looks like?
Yes. I was looking for it and I'm not sure if I located that.
Okay. So let's see if this is big enough. So the tortoise commands, there we repeat them. That's anything is ignored, and there's the F and the end region.
Can we look at the imports too? Sometimes that's
You wanna
helpful
see?
for me because I'm like, oh,
Yeah.
is this something you wrote or is this truly? Oh, wow. Okay, continue. Yeah. So this is all in the Canvas code too. I was looking at that and it's just strictly Java AWT. So really cool. And for folks that does not work with Java AWT, I'll look for that and link that.
It's horrible. I hate working with AWT. That's why I wrote those little functions around them so that I can like hide the AWT stuff away somewhere. Okay, so the tortoise, it's an extension function on the graphics 2D so that I can draw on the canvas. It's got a little bit of state. It remembers the X and the Y and some other state information. And then if you look at what the tortoise does is, it's got a array deck for the stack because it's going to have to remember where it was before.
This is pleasing. I was like, yeah, it kind of works like a stack because it responds one by one, and
yes.
So clever. I love that. So cool. Continue.
Okay, so here we're setting up the start state. And then this blueprint is the string that comes out of the plant. And for each character inside the string that comes out of the plant, it's just got a when that just jumps, that acts on every single character. So if it's either an F or a big F or a small F, there, it just draws a line. Because this is an extension function on graphics 2D, you can make this tortoise go on a canvas because it's got the graphics 2D. It's an extension function of graphics 2D, and graphics 2D object has a bunch of stuff inside it. So because it's graphics 2D, you can draw a line. So it calculates what the next X and Y position is, and it draws the line. If it's a plus, it just changes the angle of the state. If it's a minus, the same, it changes the angle of the state in the other direction. Okay, this one just changes the pen size, and then here's the stack stuff. So we're popping off the stack. There's the bracket that pops off the stack. It just takes the stack and it removes the last one. And if you put it onto the stack, it just adds its current state onto the stack and returns its current state. So that's the sum total of what the tortoise does. And so that's how it can read each character and then draw on the canvas. Okay.
I'm going to spend a lot of time learning from this separately because, there's draw functions everywhere, trying to do it in Compose and all this. So it's really great to have additional examples to learn about general drawing and Canvas stuff with. How did you figure this out?
There's a lot of examples around the Lsystems. People like to code them up, but I wanted to use them in Kotlin, and I wanted it to be a simple way to do with extension functions and with the I wanted the syntax to look like this. I wanted you to be able to say canvas, and then I wanted to say take tortoise, start here, there's the start position. This is the angle that you've got to change because that's 90-degree angles that it's changing. And then just give it a string and get it to draw.
Very cool.
Okay. So on the internet, there are lots of examples of these Lsystems. There are a lot of these tree type structures. There are a bunch of them. I tried out a bunch of them to see which ones I liked. So the one that if you search for this on the wiki, the one that comes up is this one. It starts with a minus X. Now, X, the tortoise doesn't know what to do with X, but it's okay because you can have it in the string because you can use it as a placeholder. Because you can see if you find an X, you can replace it with a string. And then F to double F. So these are the rules. starts with minus x. These are the rules. And here we've got it going 6 times. So if you run this, the plant will have a blueprint of a string of what the plant looks like inside. And then you just take the canvas and the tortoise and you give that plant blueprint to the tortoise and then it will draw it. So we're going to run this and we should see the Wikipedia plant appearing. Okay. Now the next thing is that this plant, no matter how many times you repeat this, it's always going to draw the same plant because the plant makes where the plant is and the tortoise just draws the strings, the characters in the string. And so the plants, they all look the same if you run it like this.
Okay.
We can see it like this. So here I've got 3 of them. I've got 2 plants. They're using the same formula. The P1 plant will always look the same as a P1 plant. But then I decided we need to get some variation somewhere. We need to get some way to give some variation to these plants. And so I made another method on plant, which is called Sprout. And what Sprout does is it takes a list of probabilities. So it's like having a dice roll inside the plant head. And then when it generates the plant, it sometimes applies the rule and sometimes doesn't apply the rule. So 9 out of 10 times it applies the rule, but maybe if this probability is 0.9, it uses random numbers and then it sometimes doesn't apply the rule. So what we can see here is if I've got the tortoise running 3 times and I'm going to make it draw the P1 blueprint and the P2 blueprint, and that one's green. So let's just run this and you'll see. So you can see they look slightly different. This one uses different angles, but if I run it again, the 2 black ones will stay the same, but the green one should change. Let me see, I can run it over there. You see, okay, so there, one of the times it didn't apply the rules. And so it's kind of like a stunted plant because it has variability in the way that it constructs the plant. That's one way to add some other kind of variability.
Okay, I think I'm getting it. Yeah, this is making sense. Yeah.
And so what you can see here, the benefit of the notebook is I can mess with the code. I can change things. I can, for instance, change this variability over here to another value and run it again and see what effect that has. Now, the other way to make things variable is to not make it when you create the plant string variable, but to make it, instead of a tortoise drawing, let's have another animal that draws, not a tortoise. We have something that's got variability in its drawing mechanism. So if you've ever watched a squirrel on a tree, a squirrel will like stop and then it looks like it's picking any random direction to run in. So if you take that characteristic of a squirrel that runs into a different direction, I'm calling it the stochastic squirrel. If you change the way that the drawing algorithm works so that it's got variability in the angles that it changes, you're also going to get a plant that grows differently. So if I go back into the Lsystems, I have the squirrels that live here. So instead of the tortoise, I've got a squirrel algorithm. And the difference that it has is that I need to go in here. Where is this? Okay, here. The difference is that it actually, instead of, it's got some jitter. And it jitters the angle that it turns. So where the tortoise always turned the same angle when it was drawing, the squirrel doesn't do that. The squirrel changes the angles. The rest of it is exactly the same. It's just here when it changes on the plus and the minus, instead of changing to a fixed angle, it's got this random number that it drops into the angle.
Never in my life I thought you could capture squirrels run in a mathematical equation.
Well, I mean, it's not a real squirrel run.
It's not a real squirrel. Yeah, I had some follow-up questions, actually, because I imagine here it's going to come out as a pattern. Wait, is there a randomized function in there? Because that was the next part. I was like, I suppose you could capture it in a randomized function. So it would probably be like the time basis that we could see the pattern.
Yes.
It would be cool to see it kind of like play out one by one, but I think it just renders the static, right?
Yeah, okay, but I'll show you. If
Ooh.
I go back to the forest now. So let's do the squirrel code, because I've got the squirrel, I've got some squirrel code. So I've got the same plant, but now I'm getting the squirrel to draw the same plant that the tortoise just drew. So if I run this, okay, so it looks like that, but if I run it again, you see, it actually looks different every single time you run it.
Hold on. Let me zoom in a little bit. One more time, keep going. Oh man, it's like changing direction in terms of the winds is what.
Yes,
and like it's even like you know what I'm talking about? It's opening and closing the branches.
Yes.
Okay, yeah.
It's because it's the squirrel that changes direction, and when it either rotates left or right, it doesn't rotate left or right by the same angle anymore. So the lengths of those little branches are the same, but the angles are all a bit more random because it's stochastic. It's not deterministic like the tortoise anymore. Okay. So I've got the shrub now. I've got the squirrel. I can draw the shrub. So then I tried out a few of these things to see if I can find another tree that I like. We can try some of the others, but let's just do this one, because this is the one that looks a little bit like a Christmas tree. It uses a different formula for the plant here. Let me draw that one. And you see it looks like that. But because it's a squirrel drawing it, not the tortoise, if I run this a few times, you'll see, okay, there's this short one. So
yeah.
I think this plant uses sprout. So it uses both of these ways of making the plants less deterministic. This one has like some rules about some determinism about when it applies these rules, and then I get the squirrel to draw it. So we've got some variety here. Okay. So now we have a shrub, we have a tree. Now I want some more. I want more seedlings, and I want a forest of things. So what I did is I made a nursery notebook. Am I in the nursery? Nursery. Okay, so for the nursery, I just have some of these. I have trees, I have shrubs. I make a list of these. So I make a list of the trees and shrubs, which are just the data objects with those strings in them. And then what I do is I create a data frame. Now, why am I creating a data frame? Because what's inside the plant, I want to have a bunch of them. And I want to add parameters to them, and I want it in a CSV file. I want to be able to store it in a CSV file. So these data frames, you can store them as a CSV file, because then in the other notebook, I can read in these CSV files. So what I'm doing over here is I have a bunch of these plants. This is what the data frame looks like. And this is just the data objects inside a table. So this is a bit more of the data science part of it. I'm creating a bunch of data with code. I could have gotten this bunch of data from an API call or from any other place or from a connection to a database. But for the purpose of this example, I'm generating the data with code, and then I'm writing it to a CSV file. And I'm getting it to store some stuff around, whether it's a tree or whether it's a shrub. Let me see if I can scroll up a bit.
That's so fun. Okay, cool. Yeah. Wait.
Is it in the foreground or the middle ground?
So you created those emojis all the way in the beginning? They were so tiny. You did say that. It's just these values are saved, and then that's how you're able to quickly create like a more.
Well, the emojis on the first screen, on the first notebook, they were generated by the code. And this is just because I don't want to generate a bunch of these trees and plants on the fly now. I wanted to show you how you can use a data frame to generate a bunch of these plants. Now, if I go back into the nursery, into the forest. So now on disk, as part of the project, I have a CSV file. So here I'm pulling stuff in again. You can see this percentage use. It's like pulling in a library, and I'm saying I want to use the data frame library. And then I'm getting the plants from the CSV file. So here I'm reading the CSV file to get the plants. I hope this is going to work. Okay, hang on.
Okay. The issue here is, BOM input string builder.
Okay, it's having an issue with this.
No such method error. Yeah. It's not recognizing the percentage sign for some reason. Maybe a clean would fix it.
Yes, let's clean. Okay,
when in doubt.
Absolutely. So here, okay, there's this room over here we can clean. And so this is a good demonstration. This shows you what it looks like if you mess up your notebooks. And it gives you an error. Then the output is an error like that. And so that's interesting because that's one of the things about notebooks that's maybe not so intuitive, but a little bit weird, is that if you're running them from the top, you can have cells at the bottom that are dependent on things in the top of the notebook.
Yeah, like it doesn't actually catch up. Like you're not reloading the entire page. You're just refreshing that particular part that you played.
Yes, and it's going to use what it had before.
Okay. Got you.
And so
it caches it. Yeah, the previous
so because of that, what I found was that the pieces of code that I wanted to use, often like the canvas and the Lsystems and the plants, I put those into C files, not C files, into Kotlin files.
Right.
And remove them out of the notebook so that the notebook has the things that are changing that I can mess with. And if I'd messed with those classes up in the notebook, you sometimes get weird behavior because you're running a cell out of context. So if I say this, it's going to run all of them, and hopefully
you press the play all button for that to happen.
Yeah, because what that does.
I was going to ask that. I was like, how long does it take if we play it all at once? Is it actually playing it all at once, even though we're not looking at everything?
Yeah, so what it did is it actually went back, and then one by one, it's playing the cells from the top. And so theoretically, we should get the plants. Oh, no, we're not getting the plants.
Maybe invalidate cache.
No, I don't know why.
Let's see. Sometimes people are, it just says no such method error. I mean, I feel like that's always a Gradle-related issue.
I can run it like this, but this is but this is not building the notebook. This is building.
Yeah, maybe invalidate cache and restart just in. Because the other question I had was, I was like, wait, what's that broom one? I didn't realize that was the clean, because there's obviously the IntelliJ clean refresh, the cache for the entire IDE. And then this is just specific to the notebook, this cleaning function that we're looking at.
I'm going to try something else.
And folks that are watching, feel free to drop in comments, suggestions. I'll definitely comment on it so far. But, what is going on now?
Oh, no, this is because it's the wrong data frame.
Oh, that'll do it.
Ah, okay. It
classic
fixed itself. Okay. This is one of the pet peeves I have with the notebooks. It's not like,
is there no suggestion?
No, it's like it's living in its own world. And in fact, if you look at the bottom here, it should be running. It sometimes shows the Java icon. I don't know where the Java icon went here now, but it sometimes
maybe
shows
because it's presentation mode.
I don't know.
Oh, yeah. I mean, I actually am seeing in the right top corner, like one error, some warnings. I'm just not sure if I'm seeing the feedback exactly. Maybe I missed it.
Okay, it thinks it can't resolve this, but this might be like a notebook thing, right? But
this has to be. I'm like, there's no red squiggles. I think that's what's throwing me off.
Okay, so I mean, this is working now, even though that's red, because I can see here that it's displaying the data frame for me here. So it's got all my plants there. The cool thing about these data frames are you can modify them. Let's see if this works. Okay, so what I'm doing now is I'm taking these plants and adding some more values to it. I'm adding some more values to the set of data. And I'm in fact also removing some values. So if I run this one now, so this part is the thing that data scientists would do. They would pull in a bunch of data. They would look at the data. They would extract some of the data. They would delete some of the columns. They would add some columns. They would do some calculations around the columns. Because what you can see here now is that I have, okay, so there's the blueprint string. And there's some more data. And I've got some colors in here. And I've got some various information about it now. And so I have enough information now of different kinds of trees and different kinds of shrubs to be able to draw all of them now, because I've got the canvas and I've got the tortoise. So let's see what this looks like if I go. So let's have a look at this. So these seedlings are the ones that come from this data frame here, which has got all of this information here. This part there in the beginning says how to draw the tree. It says if it's a tree or if it's a shrub. It says where it is on the plant. It gives it some X and Y coordinate to start. It's got some color information and some more information. And so if I run this now, you can see here, okay, Sky Earth will just give me a gradient. I hope this is going to run. No. Canvas. Import canvas. Okay. Oh, it's going to want all of these now. Oh, no, there, it's better. Okay. No, don't update. Okay, so let me run this. Yes, okay. So Sky Earth is going to give me this gradient, this gray gradient. And I've got the first batch of trees that I'm drawing, which comes from the list of the forest. I've filtered out if they're trees and if they're in the background. And then I gave it to the squirrel to draw. So there's the squirrel function that we saw from before. And the forest here will just, for each of the strings that's in the forest data frame, it will draw the trees in the background. And if I uncomment this now, it's going to draw the next batch of trees.
Wow. So cool.
Some more trees in the foreground.
What do we filter out the last two? The lines 11 and 12 is what we filtered out in order for that to happen.
So it's the background trees, the middle ground trees, and the foreground trees. So they I've drawn them in from the background to the foreground. And in the front here, these are the, if they're not a tree, then they're a squirrel. Then they're a shrub, not a squirrel. The squirrels draw, then they're a shrub.
One thing I'm noticing is how quickly the runs in here run. Is this like a run within a regular Gradle run?
No.
Tell me more.
Okay, it appeared. Look here. There's the Java runtime guy.
Mm-hmm.
And so the notebook has this runtime environment that it runs. And it's like it builds up. It's like a ripple. It's like yeah. So
it's crazy.
It doesn't do a Gradle run. It doesn't do a Gradle run. So I think the Python notebooks also do that. The Python notebooks, because Python is interpretive, can do this easily. But so this is with using Kotlin though, and then they've made it such that you can get this interactive kind of feeling by just running each of these cells. And so what I wanted to show you here now is that you can have an ID, and then this display thing is this display, and this is the same as giving the image out. And at the moment here, I'm just saying, take the forest image and display it with this ID. I'll show you now why I want to do that. Because, okay, this demo is going to be not as nice as it was before because they fixed something in here. Okay. See this runs? Okay, so this is flashing now. And what it's doing is, the reason it's flashing is because you see there's a little loader at the top there. There never used to be a loader. So in the previous version of the notebooks, this would animate because you would get the image updating. I'm just waiting for it to finish because, let me stop it, stop.
This is a current Jupyter Notebook issue.
No, it's not they thought they made it better. And so they're giving me a loading spinner when they're rendering the image, but that makes it flush. And before, there wasn't ever a little loading spinner when they were building up the image. And so it would keep the old image and then just swap in the new image and swap the new image in. And what I'm doing here is I'm drawing these little pink dots, like either snow falling or little petals falling, blossom petals falling, and it would animate. But now, with the way that they've changed the notebooks, it doesn't animate. The piece of code here that's interesting is if you wanted to use coroutines inside the notebooks, you would use the same percentage use and it would pull it in. Or you can use this at file, depends on syntax, that you might have seen in a Kotlin script, this syntax over here. And why I'm showing you this is because you can actually give it an exact coordinate for a particular library. So you can pull in any Java library or Kotlin library that you want into the notebook if you want to use it. Because what I'm doing over here is I'm pulling in the coroutines library, and I'm just running in a coroutine, and this is just a way to draw those petals. And because I've got the ID of that image at the top, and I'm saying update display, I'm not drawing a new image. And basically from this code over here, I'm updating this previous image out of a coroutine.
Okay, cool. Let's keep going.
Yeah. So that's basically the final walk through the forest. So at this point is the point where it's the contemplation point. When you're walking in a forest, you can stop and think about it. And so what I like about the notebooks are the fact that you can fiddle and tweak and change and interactively see how code responds. Because if you're on an Android phone, you need to run and then run it either on the emulator or the device. Or maybe you can look at things in preview. But sometimes if you just want to fiddle with the code and just immediately get instant gratification of what does your algorithms do or how do things work, then the notebooks are great for that. Especially if you are a data scientist, you can maybe plot some stuff and see how the data changes. Or if you, with these little small functions, you can actually also draw on the canvas using Java libraries. And the fact that you can use those percent uses and pull everything in means it's a really sort of a malleable environment. But being malleable like that, it's got what we just saw before. I'm so glad it crashed like that, because sometimes I do a run like this and it runs through perfectly and people think everything's perfect. But it's not, because it's got this runtime thing at the back where it's executing the cells one by one after each other. And so sometimes there's weird things that happen like that and behavior where you can't necessarily predict exactly what's happening. The other thing is the actual notebook itself is a JSON file. So the pieces of code is in JSON. So you can check, that's if you look in the repo, you check the notebook in, and it's actually GitHub can read these notebooks, and because it's JSON, it knows how to render them. But the problem is that these images that you see inside here, they are also included, the output is also included inside of the notebook. So sometimes when you're comparing, if you want to use Git to push these notebooks up, you'll see it looks like there's like a bunch of changes.
Could we see an example of this? Oh, yeah, like the JSON files and stuff? Okay, cool.
I think, I wonder if I've got a browser up. Okay, we can jump into the repo. Let me just do the last slide, which is.
Oh, sorry.
No problem. There's okay. This is someone not. Oh, I know why. You see, here's the thing: the show method doesn't run, and the reason is I didn't run it from the top, and the show method is living at the top here, which is very absolutely classic notebook. Okay, so now the show method will work.
You have to run every single one in order for it to work. That's very interesting.
Yeah,
and
so
the red text keeps throwing me off. Like instead of the red squiggle, the red text, I just keep not seeing it until I see the little red flashlight or the light bulb.
All right. Okay. So this would be the final slide, which is the QR code for the repo. You've got that in the chat already. And if you go into the repo, then it's got all of these links and all of the stuff that's in here with all of the notes and all of the references to all of the maths and everything in there. I'm going to see if I can pull up a a repo. Actually, you know what I'm going to do? For a moment, I'm going to jump out of presentation mode.
And folks, this is now the time to ask whatever questions you have as well. We're just kind of going outside of the talk at this point and diving around into implementations around this Kotlin notebook. I had some other follow-up questions too, like the IPYNB. Is that related to the Jupyter Notebook file format?
It's the extension that is the Jupyter Notebook file format, but it's not a it's that P in there is supposed to refer to Python, but it's not. It's Kotlin. So if the file is that extension, then in GitHub it understands it. So here, this is like I did some changes in that walk notebook. So what JetBrains has done, which is really awesome, this is the diff. This is the diff of what the notebook was before and what the notebook is now. And what they actually do is they compact the output here, because there was an image over here. There was an image, and they hide that because they can see the diff tool inside IntelliJ understands what this looks like. I don't know if we could actually have a look at. I know what I'm going to do. I'm going to go like this. I'm going to copy this, and I'm going to paste it. And I'm going to change it to text. If I change this to text, we'll be able to see what it looks like underneath. Okay, so this is what the JSON looks like.
Ooh.
I should change it to JSON. Rename, because then it's going to syntax highlight for us. Okay, so the whole of the notebook looks like this, and you can see it's got the cells, and it says if it's a code cell or if it's a markdown cell. And then there's the output. You can see here's the output. And it's saying the output is a buffered image. And there it is. And that's just literally base 64 encoded for a picture, which is why every single time you run the notebook, you're going to see a diff on that line. Because the output changes.
Isn't that silly?
Well, I mean, it's cool.
I mean, it's good. It's a good thing to do. Yeah.
It's cool because that's the way the notebooks work. It's just that it means that the diffs are more difficult to read when I make changes. But that's why the diff inside the IntelliJ is actually better, because they understand the format of the notebooks. I do want to see if I can just pull it up in GitHub, because then you can see what that looks like. Okay, this is dark mode. Sorry, people, for your eyes. But if I go inside here, there's the Forest notebook. And this is, in fact, GitHub that's able to render notebooks and show you what it looks like. It doesn't have the pictures in it, because if it's got the pictures in it, those JPEGs, then it's too big. Then the whole of the thing won't render because it's too big. Okay, that one didn't render properly over there. There you can see there is a version with the output of the rocks and the stones and the trees. And it should actually have something. Okay, this you can't see because it's black on black. Maybe I should change. I should make it be white. That's what I should do. Let's see if I can go to settings now. Okay, I'm not going to mess with it. But basically, that's the crux of it. You can see notebooks are represented differently in GitHub. As well. Okay, that's it.
Wow. No, this was an absolute trip of a talk. I really enjoyed this. I feel like I learned 2 or 3 things at once.
Yeah. Okay,
yes. But yeah, thank you so much for sharing this. And this was the Kotlin Conf 2024 talk.
Yes.
Yeah, I really enjoyed this. How do you submit this in the first place?
Are you saying, why did I submit this?
Yeah, like how did you stumble on this project? It's such a neat idea.
Well, I wanted to try the notebooks, and you can in Compose, you can draw on the canvas really easily. And then when I was messing around with the notebooks, you couldn't draw on the well, you could draw on the canvas, but you had this clunky AWT stuff that was really irritating.
Yeah,
So I thought, well,
yeah.
how can I make it easier for myself? And so I wrote that little function to do that, to get that out. And then I thought, okay, now I can draw circles and squares and dots on a canvas. Do I really want to draw circles and squares and dots on a canvas? No, I don't. What other cool things can I draw? And then I started searching on the internet again. And a long, long time ago, I was learning about fractals, and I kind of liked them then and still like them now. And so I thought, well, maybe I can draw that. And then I started just messing around with it and started. And then once I had the pieces, I wanted to put it all together in a nice story, which is like a forest walk.
It's incredible. I mean, that's basically a PhD topic, and it was boiled down very well into like a very a pretty concise talk. I always enjoy those kinds of talks where it's like hard to even verbalize what it is that I get, but I can see the images in my head and I can see the movements, and there's that computational thinking that goes hand in hand with kind of playing with the features, especially with the Kotlin Notebook. I do have maybe like one or two more questions. Is there follow-up related to this talk, like how to set up your own first notebook and stuff like that?
Yeah, there's JetBrains documentation, but maybe that would be an interesting blog post to write.
Oh, yes, that would be wonderful. Not to give you homework or anything like that.
No. But if you go to this repo, there are links about the Kotlin notebooks that take you to the JetBrains documentation on how to do it. But it's not really much more difficult than just going file new. I mean, you can go like this in your project and you go new Kotlin notebook. Amanda. And we have one.
Right
now,
there.
if I just go print line, hello world, and I run this, it says hello world. So it's not really much more difficult than that. And then now, for instance, if I wanted to start a new canvas, if I open a new, let's see, open a new code. Or let's see if we can say, wait, no, here, main. Okay. Let's ask the AI, can you use the...
Is that Junie?
No, it's not Junie. It's just the AI system. Go tortoise method.
The AI that comes with the Kotlin Notebook?
It's the AI that comes with IntelliJ, the AI assistant. The canvas method, and use a new plant to do this, and look at a forest dot IPYNB for an example. I don't know if this is going to work. I didn't. We're off script now. It may or may not work. Oh no, it's doing let's plot.
Okay.
No, it's not working.
Wow.
It's not going to get it right.
Okay.
If you did that same prompt in this notebook, I've tried it out. It does draw. It makes different plants, and it draws from the AI will draw different plants. I think it's because we're in a new one, and so it doesn't manage to. It doesn't manage. It sort of sees that it needs to do some stuff.
It seems like it has a hard time catching up with. It feels like you have to run everything else first before you run this.
No, I think because this is a separate notebook, it doesn't have the context of this one. If we did the same thing over here, if I was in, say I was here, and I made a new code one, and we said AI, draw another plant variation, and use the go squirrel to draw it. Let's see if that works. It might get that right. Yeah, see, because the context is this notebook, it figured out another plant, and there it's using the go squirrel method. It won't be able to get that right, I don't think. So let's just do that. And if I run this, who knows what's going to come up? Oh yeah, okay. The AI drew another plant, but it's because the context for that AI query is this particular notebook. And if we're in this notebook, it doesn't have any context. It's only got hello world as a context.
Gotcha. Cool. Wow. This was a lot of information. It was a lot of information. I learned a lot today. Yeah. Is there anything else that I feel like my computer is threatening to shut off for some reason? I think I'm having some technical difficulties with this one. So if I get cut off, that's the end of it. But yeah, are there ways we can like follow you online and follow your work? And I guess I can link the actual Kotlin Conf talk as well. And yeah, what are ways that we can like follow your work and keep an eye on anything else you work on?
So that GitHub repo, my GitHub account, that's where I post all of the code snippets and code samples that I have. And then my website is just maiatoday.net. So it's just that's the website. And then I'm on LinkedIn, I'm on Blue Sky, I'm on Mastodon. If you just search for Maia Today, and if you go on the website, all of my about links are in the on the website as well.
All right. Great. No, we'll be sure to, I think I'm going to double check the meetup page and make sure all of that is linked up. But yeah, no, I'm getting worried about my computer. It is flashing rapidly. Yeah, I don't know. It was working fine until today. Thank you so much. And thank you everyone for sticking around and watching. I hope you enjoyed the meetup. Thanks again. And yes, have a good evening and a good day, depending on which side of the world you're on. Thanks, and keep an eye out for other meetups we do in person and we do online occasionally as well. And don't forget to check out the comments for all the code related to what we've been talking about, the CFP for Chicago Kotlin User Group. Thank you all, and have a wonderful rest of your day.
Bye, everybody.
Bye. Okay.